Hello there, Mr. Sutton bringing you the first in a series of lessons on conic sections. In this one, we'll deal with circles. Specifically, we will be writing equations of circles. For the application here, we're going to figure out whether a Spacelab will cross a certain point in space. Now, you might be a little confused about the title of this whole chapter, conic sections. I mean, we're talking about conic sections, but now we're talking about circles in this lesson. What's the relationship? What do cones have to do with two-dimensional shapes? So if you take a double-napped cone, that's this crazy-looking thing, and cut it into pieces, we can actually form four different shapes. One of them, formed right here, is a parabola. If we cut the cone in these different ways, we've got a circle and an ellipse. And then finally, if you slice the cone this way, and you get kind of these parabola-looking things at the same time, these are actually called hyperbolas. To get things rolling, let's say we have 2 points on a graph, x comma h and h comma k. There's a certain distance between these 2 points, like any 2 points. The distance formula tells us the distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. Basically, Pythagorean theorem in two-dimensional space. If we take all the points a certain distance from a fixed point, h comma k, we get, ooh, look at that, a circle. And the distance between those 2 points becomes the radius. So we could rewrite this distance formula as square root of x minus h squared plus y minus k squared, and that all equals the radius here. The circle formula, you basically just get rid of the square root by squaring both sides, so we have all the stuff inside the square root equaling r squared. H comma k is our center in this setup, and then r, whatever's being squared over here, turns out to be our radius. So that's our little intro on circles. Given this information, pause the video and see if you can write an equation of the circle described below with a center of -4 comma 0 and a radius of radical 7. All right, let's see how you did. Now, all you had to do was plug these numbers into the circle formula. So we had x minus -4, or x plus 4 squared. We had y minus 0 squared, or just y squared. And then radical 7 squared is just plain old 7. We're going to get a little more practice with circles and do a real-life application while we're at it. Major Tom's spacecraft is running low on fuel. He's stranded at a point shown below, right here, 3 comma -13 we'll call this, and a Spacelab is orbiting on a circle with the center and the radius shown. So here's the Spacelab, here is the circle, ooh, isn't that fancy, and here's the radius of that circle, 7. Based on this, will Major Tom be rescued? Now, it kind of looks like he's on that circle that Spacelab's orbiting on, but we're in space, right? I mean, maybe this is like 500,000 miles. I mean, who even knows? So it'd be nice to know if he's exactly on that circle and is going to be rescued. How can we figure out if a point is on a circle? Well, first we need the equation of a circle. So pause the video and find the equation of a circle with these properties. All right, let's see how you did. So we'll have x minus 5 squared and y plus 6 squared equals 7 squared, 49. Now, how do we know if a point's actually on this circle? Well, we just have to plug the point in for x and y, and if it comes out true on both sides, the same on both sides, we know we're on the circle. So plugging that in, we can write 3 minus 5 squared and -13 plus 6 squared. So this is going to be 4 plus, let's see, this is 49. Definitely doesn't add up to 49. So unfortunately, Major Tom is not going to be rescued. That's a huge drag. Somebody should write a song about it. So at this point, we're pretty good at figuring out the equation of a circle if we know the center and the radius. However, what if we don't know the radius? What if we have the center and one other point that the circle passes through? So we're going to start this off like all our problems, where we write the standard circle equation here. But now, instead of just plugging in -3 for h and 7 for k, we're trying to figure out what r squared is. We could do that if we also plugged in an x and a y value here on the left. Doing that would give us all constants on the left side, and whatever all this stuff evaluated to, that would end up being r squared. So that's what we're going to do. We're going to plug in the center and whatever point they gave us to figure out r squared. So we've got the point 2, and then we're subtracting a negative 3, so this will be 2 plus 3. And then we've got the point negative 5 minus 7, so that's going to be our y minus k. This is going to be 5 squared plus negative 12 squared, or 25 plus 144, which adds up to 169. So that's r squared. You don't have to square root this to find the radius, because the radius isn't what we care about. We just care about radius squared. So now that you've found r squared, plug that in with the center that you already had, and you'll get your final equation. So that'll be x plus 3 squared plus y minus 7 squared equals the r squared value of 169. We're going to do one more example here. Let's say we have the points 8, negative 2 and negative 6, negative 4 as the endpoints of diameter. Pause the video and see if you can think about what to do with these points. All right, so remember, for writing the equation of a circle, we always need the center and the radius. They did not give us the center on this one. However, if they gave us the endpoints of the diameter, the circle's center is going to be the diameter's midpoint, because the diameter goes through the center of the circle, and that's the halfway point. So we're going to take the midpoint then of these 2 points. So there's our midpoint formula. Just add the x's, divide by 2. Add the y's, divide by 2. Just average the 2 points together. So we've got 8 plus negative 6 and negative 2 plus negative 4, all over 2. So that's going to be 2 over 2, which is 1, and negative 6 over 2 is negative 3. Now that we've got the center, this becomes an example a lot like the last one, where you just have to plug the center and either of these 2 points into the circle equation. So here's our circle equation again, and I'm going to use just the first point. It's got less negatives, so I like it better. We're going to have then 8 minus 1, and then negative 2 plus 3 minus negative 3, all of those things squared, equals r squared. So this is going to be 7 squared and 1 squared, or 49 plus 1. So r squared then is going to be 50. Plugging it all back in, we've got x minus 1 squared plus y plus 3 squared equals 50. This concludes our first lesson on circles. In the next one, we'll see how to graph these things. Until then, this is Mr. Sutton signing off.